Hello everyone, I'm Sylvain Cordier, PhD candidate at LCA-ACV, and I am pleased to share with you a brief summary of my last publication in the Journal of Cleaner Production. It is entitled Environmental Life Cycle Consequences of Material Substitutions, the case of increasing wood structures for non-residential buildings. Focusing on climate change, studies have shown the benefit of using timber. However, few of them focus on other environmental indicators. Also, they focus either on a single building or on one structural system that would be representative on a larger scale. However, the environmental benefits of some projects are not easily extrapolated to the scale of a given region with a variety of architectures. So higher order effects beyond the building scale can imply changes in the resource availabilities. So the purpose is to assess the environmental consequences of a high market penetration of food structures by using a regional resolution. And the case study concerns the non-residential structures in the province of Quebec because the government has worked to increase the market share of wood building through a wood charter. It is also assumed that the wooden part added to the structures could be made of steel and concrete. So first of all, thanks to previous works, we investigated the maximum potential use of wood in the non-residential structures. We also projected the increase. This made it possible to assess the required harvest relative to the total Quebec harvest and to the forest availabilities. The discussion part of the paper presents the related results. We also estimated the potential steel and concrete substitution. So for the impact assessment, we assessed 3 substitution scenarios to consider the highest possible range of the environmental indicators. Cross-laminated timber is chosen because it is one of the most impactful and technically efficient wood products for buildings. So, for those scenarios, the added wood product displays the minimum, the average, and the maximum amount of steel and concrete. And for each scenario, the modeling assumes different grades of steel and concrete. For the summary of the result, I will just present the average scenario. So read the paper to know more about the others and to know more about the related assumptions. Here, for example, there is less steel displacement than concrete. In the figure, the black diamond indicates the total impact displacement. So if it is positive, it means the use of wood implies impact. If negative, it avoids impact. Also, even if steel is less displaced than concrete, it involves more impact displacement than concrete here. The ecosystem quality indicator is the most unfavorable one for wood products. And regarding harvesting, it is impactful mainly because of the land occupation and the fuel burned in harvesting machines. And for the average scenario of climate change, the projected use of wood in 2050 can avoid 2.6 million tons of carbon dioxide equivalent. So it is equivalent to 3.5% of Quebec's CO2 equivalent emission reduction target by 2050 compared to 1990. Few words to conclude. The model presents the extent of impact displacements considering the variability in building design and material grades, and also adequate strategies and policies that respond to the current climatic urgency should also pay attention to the quality of ecosystems. Well, I hope that this summary has aroused your curiosity, so do not hesitate to read the paper. The link is below in the description, and for any question or comment, please feel free to contact me. Thank you.